A viewer writes, I thought I knew everything about house wiring until I tried to fix one of those switches where you can turn the light on and off at another switch too. Help! In the dark, Thunder Bay. Well, those switches have confounded more than one handy person who forgot how basic electrical circuits work. This is a basic switch and bulb circuit. The word circuit's the key to what's going on. The electrical current will be happy to flow through the light bulb, only if there's a complete path from the battery to the bulb and back from the bulb to the battery. It doesn't matter where in the circuit the switch is, as long as opening it interrupts the circuit. In real house wiring, the physics is the same, but there are some practical considerations. This switch is the same as my old knife switch, but nothing's exposed. The battery is replaced by a wire to an electrical service panel, and the wires come 2 to a snake. Well, 3. Let's get this one out of the way right away. It's a safety ground, and unlike my simple circuit in space, one side of all house wiring is firmly tied to the earth, usually to a metal water pipe. The white and bare wires are all connected to a common ground point at the service panel. The bare wires never carry current and they aren't part of any circuit. All they do is they serve to connect all the metal parts in the system to ground. That way, if anything accidentally happens to make an exposed metal part live, the safety ground wire completes the circuit, blowing the fuse or circuit breaker. So, for safety, you can't ignore them. But for circuit purposes, you can ignore the bare wires. The white wires are all connected to ground too, only they are part of the circuit. The black and red if you got them wires are called hot. If you're in contact with a bare wire or a white wire or anything connected to a water pipe or the earth, and if you touch a black or red if you got them wire, you'll discover why they're referred to as hot. And if you don't want to take my word for it, it's necessary to point out that doing that can cause death, so experiment if you like. Now, because of the earth hot business, a light switch has to be in the hot wire. Now, that makes a certain amount of sense. Why not switch the dangerous wire off? But there's a better reason. If the switch was in the supposedly neutral white wire, the circuit would work just as you intended. But when the light was off, a portion of the white wiring would be hot by a circuit through the light bulb. Now, if the wire bundle comes to the switch on its way to the light, the white wire just continues on through the box, and the black one's interrupted by the switch. If the power comes to the light first, and then goes on to the switch, then both of the wires to the switch are hot, and the white one should have a warning black flag on both ends. See how safety can complicate what's basically the simplest circuit? You ain't seen nothing yet. Here's a model of the corridor switch, also known as the three-way switch. The set of switches has the same task as the other knife switch, just to interrupt or not interrupt the circuit. And each switch has 3 terminals. One of these terminals can connect to either of the other 2, depending on which way the switch is thrown. So let's call them common and ends. The ends are connected to each other by a pair of wires that I call the traveling wires. The 2 common terminals become the interruption point for the circuit. It works like this. If both commons are connected to the same traveling wire, light. If either switch is changed, dark. But the other switch can always be changed so that they're both connected to the same traveler again. Light. Dark. Notice it wouldn't even matter if the traveling wires were swapped at one switch. It's really quite elegant and not too complicated. Until you do it in house wiring, that is. Just like the simple switch, depending on where the wire routes, there are several versions that will confront you in the boxes. Now, because of the extra wires needed, 3-wire plus ground wire gets into the act. It has a black and a red hot, white, and of course that safety ground. Depending on which box gets the power feed and which has the feed to the light, the white may or may not be used as a neutral. But the 3-wire piece will be between the 2 switch boxes, and it's customary to use the red and black as the traveling wires. So in the dark Thunder Bay, if you have a misbehaving 3-way switch pair, the first things to check are the traveling wire terminals. They're a different color than the common terminal and should have the same color wires on them in both boxes. Of course, in an old house with knob and tube wiring, all 3 wires will be the same color. Have a good time.